Hello, and welcome back to this ElasticSearch tutorial. In this part, we'll look into snapshots, which are a way to back up your ElasticSearch clusters, how to create them, how to create repositories for your snapshots, and how to restore your snapshots. First off, what is a snapshot? A snapshot is ElasticSearch terminology for a backup from an ElasticSearch cluster. This backup or snapshot can be either an index or it can be the whole cluster, meaning the whole ElasticSearch instance with all your indexes. One cool thing about snapshots is that they're incremental, meaning that only differences between your last snapshot and the current one are stored. This means that the storage needed for those is less than if you took a whole snapshot of the entire cluster. If you're familiar with stuff like Git, this is also how Git stores its information. Backups on any sort of production environment are a must-have, as they will allow you to recover from disasters and not lose any information that you might have if you didn't have a backup. So snapshots are a really important part of your ElasticSearch environment. Just like most anything else that we've done in ElasticSearch, snapshots are created via an API. This is called the Restore API. This Restore API can be used not only for creating snapshots, but also for restoring them back into your cluster. One thing to note is that depending on the version of ElasticSearch that you use to create your snapshot, it might not be compatible with the ElasticSearch cluster where you're trying to restore the snapshot. A snapshot of an index created in ElasticSearch 1.x can only be restored up to 2.x. From 2.x only up to 5.x, and from 5.x up to 6.x. But you can refer to the ElasticSearch compatibility documentation in order to check version compatibility. If you're restoring snapshots within the same version of ElasticSearch, then you shouldn't worry. All snapshots created in ElasticSearch are stored in something called a repository. But this repository has to be registered with ElasticSearch before you can create and restore snapshots. This is also done via an API, although you do have to register some configuration with ElasticSearch itself before you can create the repositories. Let's take a look at how this is done. In your ElasticSearch YML file, which we've gone over a little bit in a previous video, we're going to add a new line, path.repo that has an array of possible paths for your repositories. You must register your repository paths here before you are able to use them from the Restore API. After you've done this, keep in mind that you will need to restart your ElasticSearch instance. This is done so ElasticSearch reloads the configuration and acknowledges the new path that we've just registered. Once ElasticSearch is up, we will be able to register our new repository for our snapshots. Let's do that now. To do this, we're going to do a put request for the snapshot API, and we're going to pass the name of the repository that we want to create as part of the URL. Then, in the body, we're going to specify the type of repository that this will be. In my case, I'm registering a file system repository, which is going to store our snapshots within the server's file system. And I'm going to pass just one other parameter: the location of the repository, which is a required parameter. In this case, I'm using the same path that I set on the elasticsearch.yml file, because like I said, you need to register that first before being able to create your repository. Once you run this request, you should get back an acknowledged true, which means that everything went smoothly. Now that we have our repository created, we can start adding snapshots. To do that, we're going to use the Restore API path, which is _snapshot, the name of our repository where we want to store the snapshot, and the name of the snapshot that we want to create. In this case, I'm also adding a parameter to wait for the snapshot to be completed instead of just initialized, which is the default. So let's run this and see what we get. In this case, I'm getting an error because I already have a snapshot called snapshot1. So let's make a new one called snapshot2. The response is the information about the snapshot that I just created. You can see here that I have the version of Elasticsearch that I'm using, the indexes that I have, the Kibana index that was created for our Kibana installation from a previous video, and the test and Twitter indexes that we've been using. We have a state which specifies whether the snapshot was successful, and in this case it is, and we have time for when the snapshot was created, which is going to be useful later on if you want to restore a specific snapshot. If you want, to check whether your snapshot was created correctly, you can use the same path with a GET request. This one shows you all the same information that we get back from ElasticSearch when we create a snapshot. Alternatively, you can use _all, which will show you the information for all snapshots within your ElasticSearch snapshot repository. In this case, I have snapshot 1, which was the one that didn't allow me to create snapshot just now, and we have snapshot 2, which is the one that we actually just created. Then, because my snapshot contains a lot of indexes, if I just try to run it, it's going to fail. This is because a snapshot needs an index to be closed or deleted before restoring that index. You can make a partial restore so that not all indexes need to be closed or deleted. In this case, let's try to restore only the test index. Although, because the test index is open and it exists, this will still fail. And it fails with the same error. The index is open and it exists. So let's do some more testing. Here we have a query that we used earlier on another video. This query returns documents from the test index, from the test2 index, and from the Twitter index. And not only that, it uses the test index for boosting. So if this index doesn't exist, we'll get an error. Let's try and delete this whole index. We do this by doing a delete request to the index URL. Once again, if we get back a response of acknowledged true, this means that the operation was successful. In this case, that we deleted the test index. And if I try to run this query again, I should get an error. And I get an error that says that the test index doesn't exist because I just deleted it. So now that I'm sure that the test index doesn't exist, and the information is not in my ElasticSearch cluster, let's try and see if our snapshot actually does exist and actually works, which is a very important step when making a backup of any kind. When you first back up a system, you shouldn't trust implicitly that your backup works. You should try your backup so that if you ever really need to restore your backup, you will not get a surprise that the backup doesn't work. Let's see if our snapshot would save us one day when we need to restore the test index. In this case, you can see that I no longer get an error saying that the index should be closed or deleted. And if this is true, then that means that the test index should be restored and available for searches within my ElasticSearch instance. Let's go back to our search query and see if this is actually true. As you can see, I still get the same results as I did earlier, and I still get 3 documents, one from the Twitter index, one from the test index, which we didn't change and would expect to still be there, but we also get back the document from the test index, which we had deleted. This means that our snapshot was successful in restoring the test index. If you would like to delete a snapshot, you can do the inverse of the put operation. Simply change the put request into a delete request, and this will delete, in this case, the snapshot repository. Once again, I get back a message that says acknowledge true, which means that the repository was correctly destroyed. And if I try to get any information about the backups stored here, I will get an error saying that the repository no longer exists. However, just one last thing to note is that even though we unregistered the snapshot repository path from our ElasticSearch instance, this doesn't actually delete the snapshots that we already have. If I go into my server and into the path where I'm storing my snapshots, which is the path that we registered earlier, you can see that I still have a lot of information here. This is because doing a delete request to the restore API and removing a repository just unregisters that repository. You would have to manually delete the snapshots from here to make sure that they no longer exist. I hope you learned how to make snapshots in ElasticSearch, and one day find this useful in order to restore your information in the case of a disaster. In the next and final video, we'll learn a little bit about how to optimize our ElasticSearch instance and queries in order to make it work as best as possible.